Hi, Assalamualaikum everyone.
Hi,
Waalaikumsalam.
teacher.
Salam
Waalaikumsalam.
teacher. So how are you today?
Good.
Fine.
Fine.
Wow, you seem happy, okay? So have you taken your lunch today?
Not
Not
yet.
yet.
Not yet.
Hey,
Why? It's
not
already
yet.
5 o'clock.
Busy.
Busy.
So many
Not
works.
yet. Okay. Never mind. You can eat candy or cookies or whatever you want in my class, but please do not sleep in my class, okay?
All right, teacher.
Okay,
Right.
teacher.
So today we're going to new topic. But before that, I already upload today material on Google Classroom, so you guys can refer to Google Classroom. Okay.
Okay, teacher.
Okay.
Okay. So I want to show you a video, so that you can get any ideas about what we're going to learn today. I will show you a video.
What are hydrogen bonds? An attractive force called a hydrogen bond can exist between certain molecules. These bonds are weaker than ionic or covalent bonds because it takes less energy to break these types of bonds. However, a large number of these bonds going on can exert a strong force. Hydrogen bonds are the result of an unequal charge distribution on a molecule. These molecules are said to be polar. If we look at a water molecule, we can see the oxygen atom shares electrons with two different hydrogen atoms. So, in total, this molecule has 10 protons, 8 from oxygen and 1 each from the hydrogen atoms, and a total of 10 electrons, 2 shared between the oxygen atom and hydrogen atom number 1, and 2 shared between the oxygen atom and hydrogen atom number 2, and the other 6 non-shared electrons from the oxygen atom. So this water molecule is electrically neutral, but it has a partial positive side, the hydrogen side, and a partial negative side, the oxygen side of the molecule. The electrons are not shared equally within the molecule, as they have a higher probability of being found closer to the nucleus of the oxygen atom, giving that end a slightly negative charge. So the hydrogen atom's end of the molecule will have a slightly positive charge. These charged ends weakly attach the positive end of one water molecule to the negative end of an adjacent water molecule. When water is in liquid form, there are a few hydrogen bonds. Solid form, many hydrogen bonds. And when water is steam or gas, there are no bonds because the molecules are too far apart to form any bonds.
Okay, based on the video, you guys have any idea what we're going to learn today?
Hydrogen
Yes,
bond.
hydrogen bond.
Correct. So, of you has heard about hydrogen bond before,
Yes,
Yes.
but not in detail.
but not in detail. It's okay. So today, what we're going to learn is hydrogen bond.
What are hydrogen bonds?
We're going to learn about hydrogen bond. So, I will explain about our learning outcome first. At the end of the lesson, students should be able to define the meaning of hydrogen bond, explain the formation hydrogen bond and give examples, explain the effect of hydrogen bond on solubility, properties and give example, and lastly, explain the effect of hydrogen bond on boiling point, properties and give example. So for educational emphasis, so at the end of the lesson, 3 students should be able to identify hydrogen bond. 2 students should be able to explain the formation of hydrogen bond and give example. Lastly, 2 students should be able to explain about the effect of hydrogen bond on boiling point and solubility. So what we're going to learn today is firstly about definition of hydrogen bond. Second, formation of hydrogen bond. Third, effect of hydrogen bond on physical properties. And lastly, roles of hydrogen bond in daily life. So, what is hydrogen bond? Okay, based on definition, hydrogen bond is attraction forces between hydrogen atom that has bonded with an atom of high electronegativity, which is fluorine, oxygen, and nitrogen, with fluorine, oxygen, and nitrogen in another molecule. It's a bit confusing, right, class?
Yes,
Yes,
a bit.
teacher.
So I will explain more. Okay. Based on definition, attraction forces between hydrogen atom that has bonded with an atom of high electronegativity, which is fluorine, oxygen, and nitrogen. Okay, we simplify it with phone, so it made easier for you guys to understand, to remember it. With phone in another molecule. So how this formation of hydrogen bond can be happen? First, it must meet the requirement. So what is the requirement? There are two requirements. First, the molecule must contain hydrogen atom. Second requirement is hydrogen atom on the molecule must attach to phone atom. So to make it easy to remember, I prepare a tips here, which is high phone. Which is high is stand for first requirement that must contain hydrogen atom. Phone is for high electronegativity, which is hydrogen atom on the molecule must attach to the phone atom. So now, self-test. Is there any hydrogen bond in this molecule?
No.
I think no.
Why? It passed the requirement. It has hydrogen atom and bonded to nitrogen.
It did not pass the first requirement.
I know it passed the first requirement. It's
No,
bonded to
I
hydrogen
mean
atom.
it is not. There is no second molecule.
Yes, correct. It's not pass the, based on definition, the hydrogen atom bonded with FON in another molecule. So there is only one molecule, so it doesn't form hydrogen bond. So the bond between hydrogen and nitrogen atom is a covalent bond. Okay. So please do not confuse about this. Okay.
Okay, teacher.
Okay. So I want to do a quick test. So I want to call Adlina.
Yes, teacher.
Can you see the sodium chloride here?
Yes.
Okay. In sodium chloride, is there any formation of hydrogen bond?
No.
Why?
Because if we see the requirement for to form hydrogen bond, it doesn't meet the first requirement, which it needs a hydrogen atom.
Yes, correct. It doesn't even pass the first requirement. So I want to ask Howard. Are you there?
Yes, teacher.
Can you see hydrogen fluoride here? Hydrogen chloride here.
Yes.
Okay, is there any formation of hydrogen bond?
No.
Why? It have hydrogen atom. It passed the first
It
requirement.
doesn't have the FON.
Correct. It doesn't pass the second requirement. Okay, so I want to ask, okay, same goes to the hydrogen sulfide. It doesn't form hydrogen bond. So next I want to ask, Aina Soha, are you there? Aina Soha, are you there? It's okay. I think Aina Soha, I have a internet problem. So I want to ask Duha Sufina.
Yes, teacher.
Okay, Duha Sufina, can you see ammonia here?
Yes.
Is there any formation of ammonia? Is there any formation of hydrogen bond in ammonia?
Yes, because for the first requirement, it need to have hydrogen atom in the molecule, and it has the hydrogen atom, and the hydrogen atom need to bond with FON, and in this molecule, it bind with N, so it can form hydrogen bond.
Oh, correct. Good explanation. So we have a carbon dioxide. Carbon dioxide doesn't form hydrogen bond because it even doesn't pass the first requirement. So for water molecule, it has hydrogen bond because it has hydrogen atom and bonded to oxygen atom. So same goes to the methanol. It can form hydrogen bond. Okay, so let's see example. Okay, how the formation of hydrogen bond can be happen. So first, we must check the requirement, hyphen, whether it pass requirement to form hydrogen bond or not. So first, we can see the left side here, the left molecule. It have hydrogen atom. Okay, pass the first requirement. The hydrogen atom bonded to oxygen atom, FON, which is the water molecule can form a hydrogen bond. So where is the formation of hydrogen bond here? So hydrogen atom here will bond to FON, which is in this molecule, we have oxygen atom in another molecule. So it will form hydrogen bond. Yes, like this. Do you understand, class?
Yes, teacher.
Yes.
Yes. Okay, here is the explanation. If we want to explain, we must to remember the keywords electronegativity and attraction forces. So, for this water molecule, oxygen atom in water molecule has high electronegativity. Therefore, attraction forces between hydrogen atom in water molecule atom with oxygen atom in another water molecule can bind and form hydrogen bond. So, is that clear? This explanation for you? Or you want me
Yes.
to explain again?
No, I get it.
Okay. So, we move to the second example, okay? We have ammonia here. We have ammonia molecule. So, as usual, we must check the requirement first. First, whether it has hydrogen atom or not. Yes, ammonia has hydrogen atom. Second is hydrogen atom is bonded to FON. Okay, it's bonded to nitrogen. So, it can do a hydrogen bond. So where does this hydrogen atom bonded to form hydrogen bond? So it will bonded to nitrogen atom in another molecule to form a hydrogen bond. So like this. So do you understand, class? Can you follow me?
Yes,
Yeah,
teacher.
so far so good.
Good. So here is the explanation. The keyword is still same, electronegativity and attraction forces. So nitrogen atom in ammonia molecule has high electronegativity. Therefore, attraction forces between hydrogen atom in ammonia molecules with nitrogen atom in another ammonia molecules can bind and form hydrogen bond. Okay, so I want to pick randomly who want to volunteer first to explain me about the formation of hydrogen fluoride. Sorry, the formation of hydrogen bond in hydrogen fluoride. Okay, Nurul Hawa. Can you tell me how the formation happened?
Teacher, I will try my best, okay?
Okay.
First you said that you have to check the requirement. So both have hydrogen atom and they have fluorine atom. Fluorine atom has high electronegativity. So the fluorine atom in this molecule, in one of the molecule, there will be attraction forces between the hydrogen of the molecule on the right with the fluorine atom on the left. So it will bind and form hydrogen bond. Is that correct, teacher?
Correct. Okay, good explanation as well. So it shows you really understand about the formation of hydrogen bond. So here is the explanations. The keyword is still same, electronegativity and attraction forces. So first, fluorine atom in hydrogen fluoride molecule has high electronegativity. So therefore, attraction forces between hydrogen atom in hydrogen fluoride with fluorine atom in hydrogen fluoride molecules can bind and form hydrogen bond. So is that clear? So we have another example here. The ammonia and water. This is different molecule. So I want Duha Sufina. Are you there?
Yes, teacher. Yes, I'm here.
Yes. Can you explain to me how the formation hydrogen bond in this molecule between ammonia and water, starting from the requirement?
Okay. First, we need to check if the molecule have hydrogen atom, and for water molecule, we can see that it has hydrogen atom, and the hydrogen atom must bind with FON, and in water molecule, it bind with oxygen, so it pass the two requirement for forming hydrogen bond. So, in NH3, we also can see it has hydrogen bond. It has hydrogen atom and bond with N. So, hydrogen atom from O can form hydrogen bond with N from ammonia. Is it correct, teacher?
Correct. So you explain it too well. You really understand about this. Good. So there is formation hydrogen bond here. So I will explain it again. So the keyword is still same, electronegativity and attraction forces. So nitrogen atom in ammonia molecule has high electronegativity. Therefore, attraction forces between hydrogen atom in water molecule with nitrogen atom in ammonia molecules combine and form hydrogen bond. So next, we will move forward of hydrogen bond on physical properties. So before that, anyone have question regarding the formation of hydrogen bond?
No,
No,
teacher.
teacher.
No. Okay, so you can understand it well. So good. So effect on hydrogen bond on physical properties, it has two effects. First is boiling point and second on solubility. So first, I will explain first on boiling point. So a nitrogen atom, oxygen atom and fluorine atom are highly electronegative atoms. So, formation of intermolecular hydrogen bonds between the molecules. So, intermolecular hydrogen bonds are much stronger than van der Waals process. So, the stronger the hydrogen bond, the more energy is required to break the hydrogen bonds in ammonia, water and hydrogen fluoride molecules. So covalent compound that consists of hydrogen bonds such as water molecules, ammonia molecules and hydrogen fluoride molecules has high boiling point compared to normal covalent such as chlorine. So do you understand about boiling point this?
Yes, teacher.
Okay,
Yes.
so I will explain. So can you see here there is a hydrogen bond between ammonia and ammonia molecule. So I will explain about the boiling point on ammonia. Okay, first we need the keyword electronegativity, hydrogen bond and energy required. So nitrogen atom in ammonia molecules are highly electronegative. So there is formation of hydrogen bond between the molecules. So the more energy is required to overcome the hydrogen bond. Therefore, it has a high boiling point. Okay, do you understand it, class?
Yes.
Okay, so we will move to second physical property, solubility. Okay, covalent compound that consists of high electronegative atoms are able to form hydrogen bond with water molecules. So due to the formation of hydrogen bond with water molecule, compound are soluble in water. So there is example, ammonia with water. Can you see the formation of hydrogen bond here? So how to explain the solubility is the keyword is still electronegativity, hydrogen bond and solubility. So first, nitrogen atom in ammonia are highly electronegative. So they are able to form hydrogen bond with water molecule. Therefore, ammonia are soluble in water. Do you guys can follow me? Do you understand about this?
Yes, teacher, I
Yeah.
understand.
Okay. So I have a video. This video does not have any sound, but I want you to watch carefully, attentively, and try to figure out why this is happening. Okay. Okay. Have you all can see this video, right?
Yes.
Okay. From this video, I want to ask you, why there is formation of bubbles here?
I think it is related to hydrogen bond. Maybe the hydrogen bond is broken down by the heat.
Correct. This is because of broken down of hydrogen bond. Okay. In hydrogen bond, we know that in water molecule, we know that it has hydrogen bond. So it has many hydrogen bond. So as heat up, the energy to broken the hydrogen bond is also increase. Therefore, when the broken of hydrogen bond, the particles are far away from each other. The molecules are far away from each other. So that is causes to formation of bubbles. Okay, so I will continue. So we continue with rules of hydrogen bond in daily life. So why does hair stick together when it is wet? Okay, first. In hair we have a keratin. Keratin has a protein molecules and it has hydrogen bond. So keratin are polar molecule and have hydrogen bond. So when hair is wet, keratin molecule tend to form hydrogen bond with water molecule. So that's why hair becomes sticky. Can you understand it, class?
Yes.
Okay. So why it is easy to turn page when your finger is wet? So Hawa, can you explain to me why it easy to turn the page when finger is wet?
I'm not very sure, teacher, but I will try.
Okay.
As we can see from the slide, we know that cellulose in paper consists of hydrogen atom that are bonded to oxygen atom. And when our finger is wet, it has water molecule. So water molecule can form hydrogen bond with the atom from the cellulose.
Okay, let's see the answer. So correct. Your answer is correct. So paper cellulose are polar molecules. So when fingertip is wet, because it have water at fingertips here, so it can form hydrogen bond. So that cause the paper to stick with finger and easy to turn page. So why does wavy hair look straight when wet? Okay, this is because keratin, our outermost layer of hair, are polar molecule. Just I said now in wet hair. So when hair is wet, keratin molecule tends to form hydrogen with water molecule. So keratin molecule absorb 30% of weight of water. So that's why wavy hair will stick together, become straight hair. Okay, so that's all for today regarding our topic. So any questions for you from you guys?
No, teacher, understand.
Do you
No,
guys
you explain it
understand?
well.
Yes.
Okay. So if there is no question, I will do a quiz. So I would like you guys to join my quiz. So I will share the link. I share the link in the chat box. Okay, so we start now. Oh, correct. So carbon is not high electronegativity atom. So we see it. So Aina Soha on top. Okay, so Aina Soha again. Oh, it's ethanol and water. So Hawa, wow. Correct. Ammonia has high boiling point than hydrogen sulfide. So last question. Oh, correct. Carbon oxide. Okay. So you see who's on podium. Third, Aina Soha, congrats. Second, Shafika, congrats. And winner, Howard, congratulations. So now we have to summarize our lesson today. So hydrogen bonds are formed between two molecules. Second, formation of hydrogen bond must meet the requirement, which is the first requirement must have hydrogen atom, and the second is hydrogen atom must attach to FON. And lastly, covalent compound that's high electronegative atom and can form hydrogen bond. Thus, it has high boiling point and soluble in water. Okay, that's all for today. Do you have any questions?
No, teacher. So far, so
good.
good.
So good, okay. I hope you guys understand it very well. And please do the homework, okay? Chemistry book, page 163, and do activity there. So then capture and upload it on Google Classroom, okay? Before the next class.
Alright,
Yeah.
Okay,
teacher.
teacher.
Up,
Okay,
teacher.
thank you everyone.
Thank you,
Thank
teacher.
you, teacher.
Thank you, teacher. See you next week.
Okay, go and eat your lunch. Bye-bye.
Bye-bye.
Bye,
Bye.
teacher.